So we've got an organic pathway showing us how we can make polystyrene from benzene. First question wants us to state the reaction in step 1, and it wants us to identify the reagents and conditions needed for this step. So as we can see, we've got this addition of the C double bond O to the CH3 added onto the benzene. So let's think about what could cause this. This is just a basic electrophilic substitution reaction, but more specifically, it's an acylation reaction, because we take that acyl chloride, react it with the Friedel-Crafts catalyst, that being AlCl3, which would be one of our conditions, and to form the acetyl cation, or CH3CO+. Revise over the simple electrophilic substitution mechanism to see how this would occur with curly arrows and stuff. So our reagents for this would either be CH3, COCl, so our acyl chloride, which would then react with the catalyst and then become our cation, or we could actually do it with ethanoic anhydride. And our condition for this specific reagent would be our Friedel-Crafts catalyst. Now, if we had the ethanoic anhydride reagent, we wouldn't need this catalyst, so we'd just say that it would be like dry, or anhydrous, for example. So the second question asks us to state the name of the mechanism of the reaction in step 2. So step 2, you can see that we're reducing a ketone to a secondary alcohol. So for this, we're going to need a reducing agent, and that is going to be our NaBH4, and that provides the negatively charged hydride ions, which act as the nucleophiles for this nucleophilic addition reaction. So the name of this mechanism will be nucleophilic addition. The inorganic reagent within the reaction would be NaBH4, and the name of the organic product formed, so this over here, would be 1-phenol ethanol. We can say ethan-1-ol, but we don't need to because they're on the same carbon. Okay, so both of the functional groups are on the carbon 1 in this organic product. You could also do this with lithium aluminium hydride, so that being LiAlH4. Just when it comes to the nomenclature of the organic compound, alcohol is a higher priority functional group than the benzene ring or the phenol, so we'll prioritize that over the phenol group, which is why we just take it if there's 2 carbons that the ethanol is going to be on the first carbon, and then we name the benzene ring relative to that, or whatever has less priority relative to that. So just go and revise your nomenclature if needed. So the third part of the question, it asks us to show the mechanism of the reaction of our step 2 product, so our 1-phenol ethanol, with concentrated sulfuric acid. Okay, so I've just drawn out the reagents. Let's look at our sulfuric acid over here in the top left corner. So you know that oxygen is more electronegative than the hydrogen, so there will be a partial negative charge on the oxygen and a partial positive charge on the hydrogen, and we'll get a curly arrow going from the electrons on this oxygen, which is also going to be partially negatively charged, to the hydrogen on the sulfuric acid, and then that will cause the bond between the hydrogen and oxygen in the sulfuric acid to weaken. We'll draw another curly arrow, so 2 curly arrows have been drawn, demonstrating the breaking of the bond and the adding of a hydrogen to the alcohol within our organic compound. So let's consider the second step. So you've added the hydrogen on. Oxygen has 3 bonds, that means it's going to be positively charged. Because it's positively charged, this is going to cause it to break off because this is going to be unstable. Then we're going to get a carbocation over here, so we'll get, imagine an intermediate between this. If this is removed, we're going to have a positive charge here because it's not bonded to anything. And to demonstrate the formation of the double bond, to make sure that both carbons are bonded to 4 different things, 4 different atoms, we'll draw an arrow going from here to here to demonstrate the formation of the double bond to form our polystyrene. Let me just draw out the polystyrene here. So we've lost the water molecule, and we've got something that looks like this. Now I want us to draw the repeating unit of polystyrene, so let's just draw that. That's quite a simple, straightforward question. No double bonds, it's not asking us to draw a monomer here, or a single molecule of polystyrene. We're drawing its repeating unit. Now when I draw them, I usually draw like the brackets and the end, but you don't need that at all. They don't really care about that in the mark scheme. Okay, I think that's it for this video. Thank you for watching. Hope you found it useful.